make a video about how science is no longer real science and has morphed into a religion. And I don't mean this metaphorically, I mean literally. From the perspective of theoretical history, science now fulfills social functions that are characteristic of religion. And a part of this would be the whole narrative centred around climate change as an existential threat to the planet arising from human sins against nature, and as an opportunity for political theatre, and as a source of legitimacy for political control over economic behaviour. Now, talking about climate change opens up a can of worms, and I didn't want my video about science to get bogged down by this one issue. So I'm making this video to get the basic points out of the way. I want to show where I'm coming from when I argue that climate activism represents a religious and ideological phenomenon, not a scientific or empirical phenomenon. I'm not intending to disprove climate change as such, because while religious and ideological phenomena may be based on objective claims, such as that Jesus rose from the dead, they're not the sort of thing where objective facts really matter at the end of the day. The climate change thesis is a kind of free-floating belief system that doesn't depend on the logical basis of its claims, because, let's face it, most people who champion those claims have no personal understanding of the mathematical models or meteorological data supposed to underpin them. And since there are already people out there debunking the claims of what they call climate alarmism, I don't want to duplicate that. Instead, I'm going to discuss it as a socio-cultural phenomenon from the perspective of theoretical history. Now, before I became a theoretical historian, my first degree was in physics, and as part of that I did an 8-week course on computational climate modelling, because it counted as a practical module and saved me from having to do tedious things like measure the heat capacity of water. And it's something I've remained interested in. I have books like An Introduction to Three-Dimensional Climate Modelling and A Climate Modelling Primer and Numerical Adventures with Geochemical Cycles, as well as more qualitative things like Climatology, An Introduction, and The Earth's Dynamic Systems. And during lockdown, I was working through this book, Topics in Mathematical Modelling by Kit Tung, and it includes a chapter on climate modelling. And I found some mistakes. So I wrote to Professor Tung about it, and this is my email. One of the problems was in this equation, where this term should have a square. The professor had made a slip in his calculus, and I explained how if you did it correctly you got a different answer. I also spotted a mistake in this complicated looking equation. And what did Professor Tung say? He said, "Thank you very much for pointing out the algebraic error. I stand corrected. I will fix it in the next printing of the book." And we then had a bit of a friendly email conversation where he asked how I heard of his book and stuff like that. And I'd like to say this is a great book. It covers some interesting topics, and it's really because Professor Tung is so clear in his explanations that I was able to spot the mistake. So it's a book I can definitely recommend. Now, in saying I found a mistake, I'm not trying to say I found a fatal flaw in climate models. this is just a simple model for educational purposes. What I am saying is that I'm someone who understands what's involved in climate modelling, and I understand it well enough to be able to look at an equation like that and see what's wrong with it. And this isn't the first time I've written to people about mathematical errors. I also wrote to the author of Critical Transitions in Nature and Society, which is another book I can recommend, though it has quite a few mistakes. And I got the reply, "You have spotted almost all that we knew, and even some more." So I would say I am someone who doesn't just take things at face value, and I like to verify what I am reading and make sure I understand it. And I'm not just trying to brag here, I'm building towards a point that I will make in a moment. Now, as a theoretical historian, I'm also interested in the history of climate. So I have on my bookshelf things like Global Environments Through the Quaternary and Late Quaternary Environmental Change. And I have read these books, which deal with ice ages and the ups and downs of temperature and rainfall over the millennia, and talk about the possible causes of climate change and the effects on nature and on humans. And I also have books in my library like Weather Cycles, Real or Imaginary, discussing whether climate change is cyclical due to things like wobbles in the Earth's orbit. And over here I have The Weather of Britain, talking about the factors that shape Britain's climate, such as being an island in the Atlantic Ocean, and Outrageous Waves, Global Warming and Coastal Change in Britain through 2,000 years. And what theoretical historians are really concerned with is not climate per se, but how climate affects society and social evolution. And I have a load of books dealing with this. The first theoretical history book that I read 40 years ago was Climate, Man and History by Richard Claiborne, which talks, for example, about how cooler weather during the Little Ice Age from the 15th to the 19th century affected the amount of fish caught in the Baltic, which in turn affected European economic and political evolution. And then there is Climate and the Affairs of Men, Climate and History, Climate, History and the Modern World. And over here I have Times of Feast, Times of Famine by Leroy Ladurie, quite a classic. And then all the books by Brian Fagan, Floods, Famines and Emperors, The Long Summer, How Climate Changed Civilization, The Little Ice Age, How Climate Made History, 1300 to 1850. And then there's Climate Change in Prehistory, and Barbara Rosen's Civilizing Climate, Social Responses to Climate Change in the Ancient Near East. And then there's Sing Chu, The Recurring Dark Ages, Ecological Stress, Climate Changes and System Transformation. And over here there's Civilizations by Felipe Fernandez Armesto. And to quote the blurb, he in his book he adopts a unique approach using environmental categories to make sense of world history. And these people are mostly historians and archaeologists. They know something about history, about societies and about social evolution and its complexities. And I say that because you get newspaper articles saying things like climate change caused the fall of the Roman Empire. And these make good headlines because they feed into the narrative of climate change is bad, and because people like such neat factoids. You don't need to waste your time ploughing through the 6 volumes of Gibbon's Decline and Fall of the Roman Empire, or that 8 volumes of Hodgkin's Italy and Her Invaders, because the answer is simple. It was climate change. That's all you need to know. But when you look into these claims, the researchers are generally not historians, but geographers or what have you. And the argument is basically one of correlation. The climate changed, Rome fell, there's your answer. And since climate is always changing, it's not difficult to find some kind of correlation to whatever historical event you want. But these books are by people who are historians, so they start with the history and then they analyse the interaction with climate. And they can end up at very different conclusions. For example, that climate change led to the rise, not the fall of civilizations. And I have studied all this material, and I'm not somebody who has always had a closed mind to environmental issues. In the 1990s, I was a member of the Green Party. I stood for election as a local councillor. This is my election leaflet, that's me. And you can see here, global warming, sea levels to rise. I took it seriously at one time. That's more than 30 years ago. But over the next few decades, I began to educate myself with some of the books I've been showing you, and my opinions began to change. I was becoming disenchanted with the climate change thesis before it really hit the mainstream with Al Gore's Inconvenient Truth, his documentary about global warming that came out in 2006. So here is the point I want to make. I can understand the mathematics of climate modelling at a fairly deep level. I know quite a lot about past climates and about how we reconstruct past climates. I've been involved in the environmental movement, and most of all, for 40 years I have been studying the relationship between climate and social change. So you might think that on the subject of climate change I'd be considered well informed compared to, say, the most famous climate campaigner of today. Can she spot the mathematical mistakes in climate models? Has she read Leroy Laduerry's work on millennium of climate change in Europe? So, yeah, you might think that my views would be taken seriously, which is not to say that I'm definitely right, just that I'd be considered to know what I'm talking about. But in fact, absolutely not. Because I regard the climate thesis as grossly simplistic and wrong-headed, I would be considered ignorant, and not just ignorant, but actually stupid and gullible, taken in by disinformation from the Russians and the oil companies. And beyond that, I'd be considered wicked and irresponsible and selfish. So why is that? Why is it that despite my mathematical and climatological and historical knowledge, I would be considered ignorant, whereas someone who doesn't have that background is considered the world's guru on these matters? Well, it's because the climate thesis doesn't depend on facts and information or on logic and reasoning. The point is that it feels right. It feels right that humans are a blot on the earth and are doing terrible damage to the environment. It feels right that we are somehow messing up the climate as we sprawl across the earth with our factories and flying machines. For most people, this is a faith-based thing. They don't know about, and they're not interested in mathematical technicalities or in ice cores and oxygen isotope curves, or the societal response to desertification in the ancient Near East. For them, anyone who attempts to debate such issues is just nitpicking. As far as they're concerned, some experts somewhere have determined the truth, that climate is changing, humans are responsible, and we have to rethink our lifestyle. And this message is relayed and endorsed by the media, by the education system, by politicians, by big business. And a crucial element of the messaging is that it is part of your duty as a good citizen and as a decent human being to accept it and act accordingly. Because another related element is that you are part of the problem. It starts with you. The sin is in you. It's not something you can be agnostic on and leave to others to sort out. No, you are already involved, and you yourself have to do something about it. All this is an ideological mode of behaviour. There is a revelation which is communicated to the masses via authoritative institutions, and this revelation justifies or legitimizes controls over how you live. And there are some red flags that really underline how the climate movement needs to be understood as an ideological, not as a scientific proposition. First, there is the involvement of children who are easily manipulated and propagandized because they lack the knowledge and experience to evaluate properly what they are being told. It's only now, 50 years later, that I myself am beginning to understand how things I was taught in school and that I have taken for granted most of my life were tinged with bias. For instance, the Industrial Revolution was taught to me from what might be called a left-wing perspective, as a time of grinding poverty and exploitation, rather than as a time of growing prosperity and opportunity for ordinary people. Another red flag is its association with activism. These people are not handing out technical studies of atmospheric dynamics or economic modelling of climate impacts backed up by historical data. It's an appeal to your emotions. It is a moral crusade backed up by dramatic predictions of, well, who knows what. It's never really that clear, but presumably mass death, the collapse of civilization, and the extinction of large parts of the biosphere, mediated by rising sea levels in conjunction with droughts and desertification. A third red flag is the way the climate thesis provides an opportunity for political theatre, bolstering the power and legitimacy of political elites. It provides an opportunity for the great and good to come together in these jamborees to discuss issues and make decisions affecting our lives. Climate change provides the justification as they ponder all kinds of measures that might alter your lifestyle, reduce your net income, and restrict your freedoms. Are these politicians motivated exclusively by thoughts of your well-being? Well, let's hope so, but I wouldn't count on it. A fourth red flag is that there are no good effects of global warming or climate change. And this seems very unlikely. Pretty much everything has pros as well as cons. It's hard to believe that the Earth's climate, as it is right now, is the absolute ideal, and any deviation from it is inevitably harmful to society and the biosphere. The fact that we're only told about negative consequences suggests we are being manipulated. And related to this is the way that climate change can explain almost any negative development. So global warming will cause flooding, but it will also cause droughts, and it will cause heating, but it will also cause cooling and even trigger an ice age. So yes, children, activism, heavyweight politics, and the one-sidedness of the whole thing. These are some red flags that suggest we are dealing with a cultural, ideological phenomenon, not a scientific or factual one. And the biggest red flag is that we're not allowed to debate it. To question any aspect is to be a climate denier, therefore ignorant and morally bankrupt. But the climate change thesis has many moving parts, and not all of them are scientific or the kind of thing for which we have theories and mathematical models. Nevertheless, they are bundled together as a package, and either you accept the whole package or you are anti-scientific, hate-filled, and so on. Again, I would see this as exhibiting its religious nature. If you're going to become a Christian or a Muslim, you're expected to take the whole package. You're not expected to pick and choose which bits you agree with or quibble over the details. Now, personally, I tend to break the climate change thesis down into 4 issues, all of which we are required to agree with. Other people break it down differently, so I'm not saying that this is definitive, it's just the way that I have come to look at it. So the 4 issues are: 1. Is the climate warming? 2. Are humans responsible? 3. Is the warming harmful? And 4. Are the measures proposed to deal with it the right ones? All of these are debatable, but the climate movement doesn't want us to separate them out and examine them individually. You're either for or against. And these are not necessarily scientific questions. Deciding whether the warming is harmful involves value judgments. It's not something that can be churned out of a mathematical model. And deciding whether the politicians' proposed remedies are likely to be effective brings in economics and social psychology, and those are hardly disciplines that allow for only one answer and where no debate is possible. Let's face it, are politicians always right, and do governments always deliver the best solutions for their citizens? I don't think many people really believe that. So why should we think that the decisions being hammered out at these climate jamborees concerning net zero and things like that are necessarily right? But we can't question it because we are told the science is settled, even though it's not a scientific but a political and economic issue. Now, let me just run through these 4 questions and say why they are debatable. So, is the climate warming? Well, it's debatable. It depends on where you choose your starting point. If you go back 20,000 years to the last glacial maximum, then yeah, definitely, we've been coming out of a glacial period. And this is part of a series of pulses of cooling and warming that has been going on for hundreds of thousands of years. The ice caps come down, then the ice caps retreat, and we're in one of the phases of retreat. So is the world warming? Absolutely. But if you choose your starting point earlier, say around the time of the dinosaurs, then the answer is definitely no. The planet was much hotter in the time of the dinosaurs. For a start, there were no ice caps. There was no ice at the North and South poles. It's actually unusual for our planet to have ice caps. The normal state of the planet is to be much warmer than today. But every so often it goes into an ice age, meaning that there is permanent ice cover in the northern and southern latitudes. So although we're coming out of a glacial maximum, strictly speaking, we're still in an ice age because we still have ice caps. So if you look on long time scales, then we're actually in a phase of global cooling that has been going on for millions of years. What if we look at more recent centuries? Well, it's pretty well established that climate was warmer in the Middle Ages, cooler until about the middle of the 19th century, and then started warming up again. So if you choose your starting point in the mid-19th century, then it's very much going to look like the world is warming. But if you choose the Middle Ages as your starting point, then the warming will look much less, or might even be cooling. Now, while it used to be uncontroversial that the Middle Ages were a time of warm climate, and it used to be called the medieval warm period, it's now called the medieval climate anomaly, on the grounds that while climate was warmer in Europe, it was not necessarily warmer in other parts of the planet, and might even have been cooler. Well, maybe, but of course this change of language helps play down the idea that warming, which, as I said, goes back 20,000 years, is a natural phenomenon. And it makes it easier to present today's warming as an unprecedented catastrophe needing extreme measures to deal with it. The word anomaly, for example, in medieval climate anomaly, is rhetorical. We could ask, what is anomalous about it? Anomalous with respect to what? Anyway, the fact remains that whether you start your thermometer in the Middle Ages or in Victorian times will make a big difference to the amount of warming you measure. And turning to the last 100 years, the 1960s and 1970s seem to have been characterised by a run of cooler weather. So if you measure from those decades, then you will see a lot more warming than if you measure from earlier in the 20th century or from the 1990s and 2000s, which were warmer. Because look here, John Gribbin is a popular science writer, and in 1976 he brought out this book, Forecasts, Famines and Freezes, Climate and Man's Future. And the blurb says, John Gribbin examines the climate crisis in terms of world economics, food supply and politics. And what climate crisis is that? Well, the blurb begins, how much will temperatures fall in the Northern Hemisphere over the next 30 years? Will Asian rainfall continue to decline? And it goes on, the stakes of coping with climate are enormous. A 2-degree winter temperature drop could raise the fuel bill astronomically. And this cooling could seemingly cause extra winter storms, which could seriously delay the exploitation of North Sea oil. So here in 1976, people were concerned not only about global cooling, but also about us not being able to increase our use of fossil fuels fast enough. And inside the book, we have this chart showing temperatures rising to the mid-20th century, then falling towards 1970. And John Gribbin tells us, for example, that Harvests in England during 1960 to 73 were completed on average about 9 days later than during the preceding 20 years because of falling temperatures and a longer growing season. So yes, the 1960s and 1970s were cool, and people worried about global cooling because cooling causes drought, high energy bills and late harvests, raising the spectre of famine. And another person writing at that time was the economist Kenneth Boulding in his book Ecodynamics, a new theory of societal evolution, published in 1978. And this is what he has to say on page 235. The meteorologists do not seem able to decide whether the activities of the human race are warming the earth up or cooling it down. A few years ago, they were all worried about a greenhouse effect. The rising level of carbon dioxide in the atmosphere as a result of burning fossil fuels acts as a greenhouse. This, of course, would warm up the earth, causing the fear that the polar ice caps might melt and flood most of the land area where the human race lives. Now, however, the fear seems to be of a new ice age. The earth is cooling off very rapidly, with an almost unprecedented decline in temperature in the last 20 years, but nobody, I think, really knows why. So, do you get that? Writing in the 1970s, Kenneth Boulding said that in the past, when climate was getting warmer, people were talking about the threat of global warming, and now in the 70s, climate is getting cooler, and people are talking about the threat of global cooling. And of course, what happened was that just around the time that John Gribbin and Kenneth Boulding were writing about global cooling, the trend reversed and the Earth started to warm up again. And so by 1982, John Gribbin was coming out with a new book, Future Weather and the Greenhouse Effect, a book about carbon dioxide, climate and mankind. Now, only a few years earlier, John Gribbin had been writing about the terrible threat of global cooling. So you might think he would be happy that it was actually warming. But no, this book presents a picture of impending doom, only this time due to warming rather than cooling. And we can see the malleability of the climate change thesis because the cooling book talks about the failure of monsoon rains in India as an example of the problems of global cooling. And the warming book talks about the failure of the monsoon rains in India as an example of the problems of global warming. Anyway, the point I want to make is that the 1950s, 60s and early 70s were characterized by cooler weather. So whether you think the world is warming or cooling depends on what part of the graph you choose to look at. You can tell any story you want just by cropping the x-axis. So, to be clear, global temperatures have by no means been steady, whether on short, medium or long timescales. They have gone up and down, and there have been ups within the downs and downs within the ups, and ups within the downs that were in the ups, and so on and so on. And this means that whether the Earth is warming and how much it is warming depends massively on where you choose to start measuring from. Now, you could say, well, we should measure from when people first started to use fossil fuels. But since climate was fluctuating continuously before that, how do we know that that moment represents a fair baseline? Maybe you can give a good reason, but it's a matter of judgment and opinion rather than objective fact. there is definitely a debate to be had about how you choose the baseline. And given that climate has long, medium and short-term fluctuations, whether it's even possible to say what the normal baseline should be. So yeah, is the climate warming? Well, it's debatable because it involves choosing a baseline, and people can have different views about that choice. Now the second question. Are humans responsible for the warming? Well, if climate has been fluctuating since time immemorial, how can we actually tell what part of the present change is due to humans and what part would be happening anyway due to natural causes? When climate was cooling in the mid-20th century, it was suggested that it was due to human pollutants that were clogging the atmosphere and blocking sunlight. Well, what if that was right? Maybe the Earth would be warming even faster if it weren't for human-caused pollution. I'm not saying that's the case, but how do we know? How can we be sure? Well, we can only be sure if we have a rock-solid theory explaining the climatic fluctuations that occurred in the past before humans were making any contribution. And do climate scientists have tried and tested models that can explain all the climate fluctuations of ancient times? Does everyone agree what caused ice ages and what has caused the fluctuations of glacials and interglacials within the present ice age? Absolutely not. There are no rock-solid theories of natural climatic changes and no universal agreement about the causes of them or even what they were. Because otherwise all the scientific journals dealing with past climates would have closed down with nothing more to be said. But without such agreed upon theories of natural climatic change, how can scientists distinguish what is natural from what is human made? Well, logically they can't. So since it's debatable how natural climate change behaves, it has to be debatable what part of current climate change, if any, is due to humans. Let's look at a basic model of the Earth's climatic system. The atmosphere is heated by the sun. It's a bit like a pot boiling on the stove. If you look at a pot, you will see that liquid is rising in some parts where it's hotter and falling in others where it's cooler. So you get a kind of rolling motion. And you get the same with the atmosphere. Hot air at the equator rises, then moves towards the poles. About a third of the way there it has cooled off, so it sinks and flows back towards the equator. Similarly, cold air at the North Pole sinks towards the south, warming up in the process, so that it rises and flows back towards the pole. In between, the air rolls in the opposite direction in order to mesh with the other flows. The southern hemisphere works in the same way. Now let's note two key points. First, air cools when it rises and warms when it sinks. And second, when air cools, it releases moisture, which is why we get condensation on a cold glass, for example. So consider what this means for this picture. Take the equator. Here, air is rising and therefore cooling, which means it releases moisture. So the equator is not only hot, but also rainy. Now take this region about a third of the way to the pole. Here the air is descending, so it is warming up. So the air is dry and you get no rain. So this region is dry and still quite hot, so you have hot desert. Continuing north, in this region the air is ascending, so it is rainy again, though temperatures are lower because we are further from the equator. And then around the pole, air is falling, so dry, so we have a cold desert. So this picture, which is known as the general circulation of the atmosphere, is the fundamental determinant of climate. We have equatorial rainforest, desert, temperate forest, and polar desert, with different types of grassland in the intermediate zones. And if we compare this with actual global climates, we can see that it matches pretty well. The differences are caused by various complicating factors. The main one is that the Earth is divided into ocean and land in a rather irregular pattern. And ocean and land behave differently with respect to solar energy, with the ocean tending to warm up and cool down more slowly than land. There is also something called the Coriolis force, which means that winds tend to blow from west to east in mid-northern latitudes, say, and air that has blown across the ocean contains more water than air that has blown across land. So coastal regions tend to be wetter and rainier than continental interiors. And mountains also affect climate, since as air moves up and over them, it rises, cools, and releases rain. So also do forests affect climate, as they trap and release moisture through their leaves. So it's effects like these that add distortions to the basic picture created by the general circulation. And to repeat, the general circulation is driven by heat from the sun. If the sun disappeared, the circulation would stop, just as water stops boiling if you switch off the gas on the stove. And this energy input from the sun has a power of 122 million gigawatts. That is the rate at which the sun is bombarding the Earth with energy. And it moves these vast amounts of air over huge distances. And we can compare that with the amount of energy given off by human civilization, which has a power of around 2,000 gigawatts. That is how much energy humans are putting into the atmosphere. 2,000 compared to 122 million. Or to put it another way, humans' energy output is 0.002% of the energy received from the sun. So the sun has a huge effect on terrestrial climates and on where rain falls and where it doesn't. And during glacial periods, the general circulation has changed to a different pattern, with the polar cell stretching southwards and the middle cell being squeezed. Now, how did that happen? Why did it happen? No one can really say for sure. And if you don't know the exact answer, then you can't really claim you understand the general circulation in detail. And if you don't understand the general circulation in detail, then it's highly questionable whether you can say what the effects of human interference will be, and whether you can actually distinguish what is caused by humans, relatively puny input, and what is simply natural and would be happening anyway. Sure, people might have theories about it. They might even be good, interesting, and credible theories. But there is definitely room for disagreement and different shades of opinion. Now, while in energy terms humans' contribution is utterly negligible compared to the sun's contribution, it is possible that a small change at a strategic point can alter the behaviour of a much larger system, like the way pressing one button can release millions of tons of water from a dam. So humans putting carbon dioxide into the atmosphere, even though it is a small disturbance, might arguably produce a much more dramatic effect on climate. But if we don't really understand the complex workings of that system, which we don't because we can't definitively explain its past behaviour, then how can we be sure what effect human disturbances will produce and in which direction? And this is an especially good question when we consider the Gaia hypothesis of James Lovelock, which argues that the biosphere is a self-regulating system that keeps the Earth's climate under control. Now, with its idea that the Earth is essentially one living organism, and with its name Gaia being taken from the ancient Greek goddess of Mother Earth, the Gaia hypothesis is often misunderstood as being a New Agey concept concerning the fragility of nature and being in tune with environmentalist ideas. But it isn't that. It's really almost the opposite. James Lovelock first cottoned on to the idea when he was doing work in atmospheric chemistry and thinking about the role of methane, which is just 0.0002% of the atmosphere, but has an important role in regulating the level of oxygen in the air. If it weren't for the methane, the amount of oxygen would increase, and that would make things burn more easily, and forest fires would be more frequent and more devastating. And basically the entire biosphere would soon go up in a blazing inferno. Consider what happened to Apollo 1, where NASA thought they could save weight on space flights by having an atmosphere of pure oxygen and ditching the 4/5 of the air that is nitrogen, which we don't directly use. There was a spark in the electrical equipment, and in normal circumstances it would have been harmless, but in a pure oxygen atmosphere even the metal could burn, and the whole cockpit was quickly engulfed in flames, and the crew of course died. So NASA abandoned that idea. And yeah, it's very good that the amount of oxygen in our atmosphere is the level it is and not much more. And thinking about this, James Lovelock realised that it would also not be good if the level of oxygen in the air were less than it is, because oxygen is necessary for metabolism. If you go up a mountain where there is less oxygen, exercise becomes more difficult. You are likely to be more sluggish. The Mexican Olympics of 1968 were held at an altitude of over 2 kilometers above sea level, and for the endurance events that require sustained activity, winning times were much slower than usual, such as in this chart for the 10,000 meters event. If there were less oxygen in the Earth's atmosphere, then life in general would be more sluggish, or there would in effect be less life on Earth, less biomass. So the level of oxygen in the atmosphere is at just the right level. It maximizes the total amount of living activity while keeping the risk of fires within reasonable bounds. And the methane that helps maintain oxygen at this optimal level is produced largely by bacteria in swamps and marshes. One of James Lovelock's points is that while conservationists worry about animals like tigers and pandas, those animals are basically just decorative and aren't really that critical to the biosphere. It's just a reflection of human values that we put a lot of importance on big, attractive animals, and no one gives a thought to the lowly bacteria that are actually far more important in keeping the biosphere going. We rely on bacteria in our gut, for example, to help us digest food, and bacteria also help maintain the atmospheric chemistry that keeps the Earth optimal for life. And this was Lovelock's eureka. The fact that the amount of oxygen in the atmosphere is at the optimal level is not some lucky coincidence. The Gaia hypothesis is that conditions on this planet are maintained at the optimal level for life by life itself. As mammals, for example, we regulate our own body temperature to keep it at the optimal level for the biochemical processes going on in our bodies. And it seems that the biosphere regulates the environment of the whole planet to give it the properties that are most conducive to the existence of life. So it's in this sense that the biosphere should be seen as a whole, as a self-regulating organism made up of living creatures that collectively promote their own survival. And I've just talked about oxygen and methane, but Lovelock discusses other aspects of life on Earth where environmental conditions seem to be kept at an ideal level for life by the actions of living things themselves. And one of these is the Earth's temperature, which has remained in a relatively narrow range for millions of years, despite the fact that the sun's output of heat has actually been increasing as it goes through the normal cycle of stellar evolution. So another of Lovelock's points is that scientists looking for life on Mars are wasting their time. He says we can tell there is no life on Mars because if there were life on Mars, there would be life all over Mars, because that's what life is like. It doesn't cling on under a rock. Life is irrepressible. It is naturally expansive, maximizing the amount of life possible and creating the conditions for its own existence. I always think that people who regard our environment as fragile and vulnerable, talking about the fragile balance of nature and what have you, they must be people who have never weeded a vegetable patch. As a gardener, I'm constantly attacking the weeds among my vegetables, uprooting them and even blasting them with a flamethrower. But they keep coming back. It's a never-ending struggle to keep nature in check, even when you're actively trying to destroy it. Anyway, to get back to the main point, that is the Gaia hypothesis, that life shapes its environment for its own convenience. The Earth's climate is being actively maintained that way. It is a result of a homeostatic mechanism, like a thermostat keeping a house at a particular temperature. If you open the windows to try to cool the house down, the thermostat will just cause the boiler to kick in to bring the temperature back to whatever it is set to. Similarly, if the Earth's environment is disturbed by volcanic eruptions or changes in solar output or continental drift altering the distribution of land and sea, the biosphere will respond like a thermostat, bringing things back to its desired state. So when the climate change thesis was gaining traction in the 2000s, I was expecting James Lovelock to say how misguided it was, because the Earth is self-correcting. But instead he seemed to join the bandwagon and agree that we were all doomed. I thought, hang on, isn't this against your own theory? Haven't you been debunking a lot of environmentalist ideas? Shouldn't you be expecting the biosphere to adapt around any human-induced disturbances and try to keep things in equilibrium? And what Lovelock told the papers was that if the human population was about 500 million, the biosphere would probably be able to cope in accordance with his theory. But with nearly 10 billion people, it's too many, and the biosphere can't cope. Now, I don't know where he got the 500 million figure from, whether it was based on some argument or he just made it up. It's the same as the figure given on the Georgia Guidestones as the ideal population of the Earth, which is a bit strange. But in any case, it's basically Lovelock's opinion, even if there's some logic behind it. Other people might estimate it differently. And in fact, a few years later, Lovelock came somewhat to his senses, as I would regard it, saying he had been too alarmist and going back more to his point that the Earth does a good job of looking after itself. So if the Gaia hypothesis is true, there are feedbacks between the biosphere and the atmosphere that regulate the Earth's climate, and those are beyond anything included in climate models. Yet they could mean that those models are completely simplistic, like thinking that opening the window will cool the house and forgetting that the thermostat will just work around that. Now, the Gaia hypothesis is not necessarily correct, and it has come in for criticism. To me, it has the ring of truth, but the deeper point is that it is based on definite evidence, logical reasoning, and even computer modelling. So it's not unscientific to argue for the Gaia hypothesis. And there's definitely a debate to be had about how far it is right and how well we really understand the operation of the Earth's climate and how we can tell what part of climate change is specifically due to human activity. So, yeah, are humans responsible for the warming, or at least what part of the warming is due to humans? It's debatable. There can be different opinions, and no one can say for sure. And now for the third question. Is the warming harmful? Well, an old friend of mine, now deceased, used to say, why can't they see that it's cooling that's bad? As Gribbin's book on famines and freezes shows, cooling is by no means good news. During the last glacial maximum, where I'm sitting now was under a mile-thick layer of ice. Can you imagine what that did to biodiversity? Basically, large parts of the northern hemisphere were reduced to an icy wasteland where nothing could live or grow. People worry about the flooding of coastal cities due to melting ice, but what about them being crushed under layers of ice? And a colder world means a drier world, firstly because a lot of water is locked up in ice sheets, and secondly because a colder temperature means less evaporation from the oceans, and that means less moisture in the atmosphere and less chance of rain everywhere on the planet. And in a colder, drier world, crops are going to have a harder time reaching ripeness, and yields will be less, which is why Gribbin talks about late harvests and the danger of famine. And you can see news articles about how the Viking settlement in Greenland was abandoned because of climate change. And while these headlines reinforce the idea that climate change is a great threat to human society, the climate change they're talking about is not warming but cooling. As here, the Scientific American has a headline linking climate change and social collapse, while the text tells us cool summers doomed the Greenland Norse and their outposts froze to death. And Leroy Laduerry's book, Feast and Famine, is largely about the cooling that occurred in Europe from around the 15th century to the 19th century. And he describes how, as Europe's glaciers advanced, they wiped out villages and robbed people of valuable fields and pastures. One bishop led a religious procession to the foot of a glacier, praying for it to stop moving down the mountain. Glacial advance was a big worry for these people. If they heard people today worrying about glaciers retreating, they'd probably think, are you crazy? We don't want the glaciers. If they were told that the glaciers of Antarctica are melting, they would probably say, thank God for that. So yes, cooling is not a good thing, and significant cooling, like in a full-on glacial maximum, could definitely be catastrophic. And here's the thing, if we can't cope with cooling and we can't cope with warming, then we really are in trouble, because the Earth's climate has been warming and cooling in turn since time immemorial. And this shows there is a big argument to be had about whether climate change is really harmful, because obviously both nature and human society have been able to cope with climate change in the past. And if climate has always been changing, isn't it a bit dubious, to say the least, to suppose that by buying electric vehicles and building wind turbines and banning plane flights, humans are somehow going to be able to stop the Earth's climate from changing and somehow keep it at the particular temperature and humidity that it happens to be at today? It doesn't make sense. Instead of stopping climate changing, shouldn't we be learning to cope with climate change? And in any case, every book I have that discusses historical climates, whether it's a book specifically about climate or a history book that happens to mention climate, but every book, they will all say something like, the climate improved. And what they mean is, it got warmer. And then they'll say, the climate deteriorated. And what they mean is, it got colder. It's the same if you ask someone about their holiday and they say they had lovely weather. They mean it was warm. And if they say they had lousy weather, they mean it was cold. And what's really strange is that some books will do this throughout the whole book, use improved to mean warmer and deteriorated to mean cooler. And then they get to the last chapter where they discuss the situation today and they talk about the threat of global warming. So we suddenly switch to warming is bad, and it's not clear why. It's very strange. And you can have people hoping for a nice, warm, sunny day for their day off, while at the same time worrying about global warming. Strange. And people worry about the greenhouse effect. But do they know what a greenhouse is? This is a greenhouse, and it's full of flourishing plants. This is why people build greenhouses. The greenhouse effect is not something scary. It's for the benefit of the plants. And let me show you this. This is my compost bin during the winter. It's inert, nothing happening. And here is my compost bin during the summer. It's come alive. It's full of little flies buzzing around and creepy crawlies. So you can see the effect of warming. It speeds life up. It brings the earth alive. It causes the trees to come into leaf and the crops to grow and insects to multiply. And the thing is that life has evolved to cope with this, to cope with the changing of the seasons from winter to summer and the warming and cooling that occurs over the course of the year. Even over the course of a day, temperatures can easily vary by 10 degrees Celsius or more between day and night. And life copes. It takes it in its stride. It has the resilience to deal with such changes. And it even depends on these changes as part of its life cycle. And the fact that life is still going strong after millions of years of climate change suggests that it has the resilience to cope with longer-term fluctuations as well. And who knows, maybe those longer-term climate changes are necessary for the health of Gaia, just as plants and animals rely on daily and seasonal changes to regulate their life cycles. general global warming might alter the distribution of plants, but that doesn't mean the overall effect would be harmful. It could be neutral or even positive, increasing the vigour of life on this planet. So it's far from clear that warming is necessarily harmful, and it looks more like the opposite, that the natural world and human societies thrive on warmth and prefer it to cold. And lastly, there is the question of whether the policies that governments are advocating to prevent climate change are the correct ones. Well, I don't think many people would argue that governments always get it right. Don't we have different political parties and elections and parliaments because it is recognised that there are differences of opinion about social and economic policies? People may disagree about the logic behind the policies, or they may disagree about the pros and cons of the policies, because what benefits one group may harm others. Of course, in some countries there aren't political debates because the government claims it does have all the right answers, and yet those aren't necessarily nice places to live. So yeah, there should definitely be room for disagreement about what politicians are doing in the name of tackling climate change, and whether electric vehicles and wind farms and so on are really the solution. This is not a scientific matter. It's not something that can be solved by scientific models. It's a political question. And my own view is that these solutions are not the right ones. For a start, they're not without cons. People are cutting down forests to install solar farms, so we lose that amenity. And some people argue that sustainable technologies are not actually sustainable. For example, when you take into account the energy and resources that go into making solar panels and wind turbines, and later to dispose of them when they reach the end of their lifetimes. Here is a book published in 1981 where the author speaks of ecologists who do not mention that oil is burned to charge the batteries of electric cars. And in fact, you lose energy in turning the oil into electricity and transmitting it through power lines, which are not 100% efficient. So you may end up consuming more oil than if you just burned it directly in an internal combustion engine. These are all details, but they're legitimate points for discussion. And there is a whole literature on how green really are so-called green policies. To me, though, the big picture is what argues against environmentalism. I see history as like a computer game that the human race is playing, and it's a matter of continually levelling up to new capabilities and new challenges. And the next level that humans are working towards is to move into space, to become, as Elon Musk puts it, a multiplanetary species. And when we have reached that level and are spreading through the solar system, colonizing new moons and planets, and thinking about how we're going to level up again, which is to move onto the stars, then concerns about global warming on Earth are going to be totally irrelevant. And the point is that in each level, you are supposed to use what's available in that level to get to the next one. So humans should be using oil to get on into space. And once we've done that, oil will be like old technology, and we may well stop using it, like we have stopped using flint tools, because we'll then be using helium-3 or whatever it is to drive our fusion engines and so on. But if we stop using oil now and depopulate ourselves and adopt less versatile technologies like wind power, then we will never clear this level. So instead of winding down our industrial civilization, we need to be ramping it up. That is the way to solve something like global warming, to make it trivial by continuing to expand our technological capabilities. Now, that is just my opinion, and I know that there are people who won't agree. There are people who think that humans are just a pollutant on the earth and that technology is ugly. I think that is a sad point of view. I would say humans are a product of Gaia, and we are Gaia's great hope for continuing to expand and evolve beyond the limits of this planet. Because if any species is going to take life onto other planets, it's going to be humans. It's not going to be whales or caterpillars, is it? It's humans that have been produced by the biosphere for its own advancement and protection, so that it doesn't have all its eggs in one basket and is not a sitting duck for the next passing asteroid that decides to crash into the Earth. And still there are people that disagree. Fine, but the point is that this is not a scientific question. It's a matter of opinion. So it's a matter for debate. And we can bring in theoretical history here, because the historian Geoffrey Blainey identified two modes of thinking about humans' relationship with nature, and public opinion seesaws between the two. So what he called optimism, or we might say the go-getting attitude, believes that humans are intelligent, industrial civilization is great, new technology is beneficial, and nature should be harnessed to human needs. Whereas what he called pessimism, or we might say the tread lightly attitude, believes that humans are not so clever, industrial civilization is sick, new technology is dangerous, and nature should be left alone. And Blainey says that the pessimist or tread lightly attitude tends to prevail when society has a feeling of coming up against its limits, when resources seem to be finite, and when there is no new living space for people to expand into. Whereas the optimist or go-getting attitude prevails when society is expanding into effectively empty regions, and when people have discovered new resources or new kinds of resource and are enjoying some kind of bonanza. So around the turn of the 18th to 19th century, there was a sense that European civilization was reaching its limits, with little new land to discover and growing scarcities of wood, which was needed as a source of energy as well as for shipbuilding and general construction. And this spawned the Romantic movement, which espoused all the tread lightly values, and, for example, saw the life of simple tribespeople as the ideal, while deploring what William Blake called the satanic mills of industrial civilization. But with the opening up of the Wild West, and with the discovery of new sources of energy in oil and electricity, there was a sense of release, so that society and technology could start expanding again, and society swung back towards the optimistic go-getting attitude. But now we're back to an awareness of the finiteness of the earth, which is completely joined up by modern transport and communications, with nowhere left to explore. And some attribute this sense of finiteness in part to the first photos of the whole earth taken by the Apollo missions, which made people see the earth as small and fragile, not something that we can keep exploiting and polluting indefinitely, especially because at the time this photo was taken, world population growth was at its peak. And The oil shocks of the 1970s also brought home to people that oil can't last forever, and we're going through it at a heck of a rate. So this sense of constraint and finiteness has reawakened the pessimistic, tread lightly configuration of attitudes, with a feeling that the rampant growth of industry and technology is not a good idea and is heading towards some kind of crunch. But now, if we can get into space, this attitude will melt away again, because the solar system is full of energy, raw materials, and living space for an expanding human population, many, many times more abundant than what has been available to us on Earth. We'll go from having just one planet to having dozens of planets, which we will have hardly begun to occupy and exploit. Now again, there are those who will regard this as a disaster and say something like, well, people have already made a mess of the Earth, don't let them make a mess of Mars too. And so those people would like Mars to remain an empty desert for the rest of eternity or until the sun gives out. But why? What would that really achieve? Isn't it a wonderful thing to bless it with the gift of life? Anyway, I return to the point that these are not scientific issues. They involve different visions for humanity's future. And it's a political and therefore a debatable question as to whether the machinations of politicians at climate summits and of unelected experts behind the scenes at places like the United Nations are really taking humans and the planet down the right path. So that is pretty much what I want to say. I'm not trying to refute the climate change thesis. Obviously, I don't subscribe to it, but since I consider it an essentially religious phenomenon, I don't see much point in trying to disprove it, because you can't disprove Buddhism or Christianity or any kind of religious or ideological belief to its adherents. It doesn't depend on objective facts, but has some deeper kind of truth. The point I'm trying to make is, first, that the premises of the climate change thesis are highly debatable. Is the Earth warming? Well, it depends on where you choose your starting point. Are humans responsible, or how much are they responsible for? Well, it depends on how the climate would be changing if humans weren't around, and who can really claim to know that? Is warming necessarily harmful? Well, it depends on what you think is harmful, but warming is usually considered to be a good thing. And in any case, life and society seemed perfectly capable of adapting to changing climates. Are climate-related policies actually the ones the human race should be pursuing? Well, it depends on what your goals are and how you think economies work or ought to work. And these are political contested issues where people are going to have different views and priorities. So, yes, all highly debatable. And therefore these propositions we are supposed to accept as part of the climate change package are not scientific propositions, they're matters of choice and opinion. We ought to be able to disagree and debate them. But of course, the argument is that the issue is too important to debate. We're told this is a crisis, an emergency. There's no time to be quibbling over the details. We have to act now. Well, this is a circular argument, one that begs the question. It assumes the very things that are in contention. Is the climate warming? Are humans responsible? Is it harmful? And are the policies you're proposing the right ones? Those are the assumptions it doesn't want you to examine. And so the second part of my point is that because we are expected to accept them without examination, without debate or discussion. And because an informed person like myself is considered ignorant for deviating from the orthodoxy, that in itself shows we are dealing with an ideological phenomenon. This is a faith-based belief system, not a rational or logical one, not a scientific one. So that's my analysis of the climate change movement. And as I said, I wanted to get that said as background for an upcoming video on the pathologies of the massive modern social institution known as science.